Hello everyone, this is my live report for lab number 3. My name is Hyunjae Lee and let's get started. So to give a brief background of this experiment, the purpose was to measure the on and off axis magnetic fields due to the bar magnet and observe the distance dependence of the field. So the procedure of this lab goes along the line of this. We first align the phone so the Earth's magnetic north and south axis. So we have the x component on the ab close to 0. We place a meter stick so it runs from west to east and place a magnet at the end of the ruler. When we use a magnetometer sensor, in our case we use PiFox. We measure the distance from the magnet when the magnetic field has a component and the magnetic field on the x-axis has a component of 20, 70, 120, 170, and 220. Then we measure the distance perpendicular to magnet when net magnetic field is 100. So our first procedure was to find the sensor on the phone. We find the position in which the absolute value of Bx is at the maxima and By is at the minimum for the horizontal, and we find a position in which the absolute value of Bx is at minimum and the By is at maximum for the vertical. And the picture you can see on the right. And with that, we use 2 tapes and find the intersection, and that is where our sensor on the phone is going to be. And the following is the fundamental principles that are used throughout. The first principle is absolute value of B bar is equal to K times R powered by N. K is a constant, and this measures the magnetic field at a multiple distance from the bar magnet, and we will solve for N. We will also use the Biot-Savart law, which is mu 0 over 4 pi times 1 over r cubed times 3 mu vector mu times r hat, where times r hat minus mu vector. This above is a brief picture of the data we took from the experiment, and we will first of all take the natural log on both sides, and we will use the data given to plot, which were plotted using Excel, and we found that the slope is negative 3.6424. So our n is going to be negative 3.6425. These are the calculations that we have. We just figured out that n was negative 3.6425. So we put in the corresponding values, and we find mu, which is going to be 1.456372. This is the glow script that I used throughout the experiment. We created a function for the magnetic field, and we located 2 on-axis and 4 perpendicular arrows to represent the magnetic field. We located the 45 degrees off-axis arrow representing the field, and we put in the magnetic field of each row, which we will see on the next slide. So, from the glow script results, we can see that D is equal to 0.266296 meters, and the B vector is 3.85608 times 10 to the negative 6, and the X component, and 1.15682 times 10 to the negative 5 on the Y component, and the Z component is going to be 0. And on the right, you can see the glow script model with the results. And for the final questions, what if you hadn't oriented your experiment to compensate for the magnetic north and instead had laid out your meter stick on some intermediate angle with respect to Earth's magnetic field? The results would have been very skewed due to the magnetic field of the Earth. To avoid this, we took 2 separate entities to account for. To avoid this, we took the magnetic field of the bar magnet and the Earth to be 2 separate entities to account for the distinct magnetic field of the bar magnet. Second question is, what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? I believe the magnetic field would increase by almost a factor of 2. And that is it. Thank you for listening to our presentation.